Okay, in section 5.4, this is about graphing the sine and cosine functions. And one of the first problems that you have to do is to use transformations to graph each function. In this example, we're given y equals sine x minus 1. So the first thing that you want to do is compare it to the original function, well, the equation of sine x, which is y equals a sine bx, and I'm using b instead of the w, minus or plus c. Alright, so when you compare it, the variable c tells you whether or not it's going to move up or down. So if you look at the c is equal to negative 1. Okay. Because c is equal to negative 1, that means using graph transformations is going to move down 1 unit. The other thing it means is that you're going to, from the original table that's used for the parent function, you're going to subtract 1 from each y coordinate. So I'm going to write that here too. Of the parent function. Alright, so what that means is, let's say you have your parent function, which is y equals sine x. And you have your table. You have your x's and your y. Alright, at y equals 0, if you look at your graph, at x equals 0, y is also equal to 0. Alright, if you go to pi over 2, when x is equal to pi over 2, then y is equal to positive 1. When you look at pi, when x is equal to pi, then y is equal to 0 again. When you look at 3 pi over 2, and I'll see if I have room to write it, 3 pi over 2, x is equal to negative 1. So that's all I have room for. Alright, so when you have your transform function, which is y equals sine x minus 1, and as I said, that means that you're going to take your original y value and you're going to subtract 1 from it. So I'm going to subtract 1 from my y value. So that's why I have the y minus 1. Alright, so my x's are going to be the same. And there will be 0, pi over 2, pi, 3 pi over 2. Alright, when I subtract 1, 0 minus 1 equals negative 1. When I subtract 1 from pi over 2 minus 1 will be pi over 2 minus, it'll be easy to show that one. It's just pi over 2 minus 1. We'll just leave it like that. Then I have pi minus 1. And then I have 3 pi over 2 minus 1. Alright, now these are actual values. If I wanted to get the decimals to be exact, I could do that as well. So here, since I am subtracting 1 from each y value, my y's are going up and down. So I'm going to make a new graph. And I'm going to do that in red. Alright, so an original function, when x is 0, y is 0. And a new function, when x is 0, y is negative 1. So I'm going to start at negative 1. I'm sorry. I did something wrong. Now I see what my mistake is. I was looking at my x's and not my y's. Okay, so I could do this again and do it the right way. Alright, so this is going to be 1 minus 1, which is 0. This is going to be 0 minus 1, which is negative 1. And this is going to be negative 1 minus 1. Let's see, 1 minus 1, 0 minus 1, negative 1 minus 1, which is negative 2. Alright, so now I'm going to graph my new points. So my new point would be 0, negative 1. So I'll start at 0, negative 1. And then at pi over 2 is at 0. So I'm going from here to 0. Then from pi negative 1. So go down to negative 1. Then negative 2. So I'm going to go all the way down to negative 2. And then 2 pi, it only goes down 1 unit, so that's going to be to negative 1. And then it goes up. Alright, so this is my graph. Y equals sine x minus 1. And that's how you graph using transformation. So again, you compare it to the equation, the general equation for sine, which is y equals a sine bx plus c. C lets you know that you're moving up or down. So in this case, it's minus 1, so every y value is moving down on your graph. Then I showed you using a table how you find your new y's, and then you plot the points. Hopefully that's helpful.